Welcome to part 2 of trigonometric substitution. In this second video we're going to solve a very long problem using trigonometric substitution. We're going to try to find the integral, this integral. We have x squared over the square root of x squared minus 16. And we want to use this identity. We saw in part 1 of this series of videos on trigonometric substitution that when you have a difference like this, when you have your variable squared minus 16, you should try to use this identity. And we're going to see why is that. Because you can write this integral like this. Here we can factor the 16 here, that as there is no 16 here with x squared, we need to divide by 4, and we take the 16 out of the square root and we have 4. So we can write the integral like this, just an algebraic manipulation. And now we're going to make the substitution. X over 4 equals secant of t. The variable we are introducing is t. We're doing that because if we do that, here we have x over 4 squared. So we'll get secant squared minus 1, and then we'll be able to use this identity. And here, solving for x, we get that x should be 4 secant of t. If we take the derivative of this, we get dx dt equals 4 tangent of t times secant of t. That's just the derivative of secant of t. And that means that we can replace dx by this expression. So now we make the substitution. X is 4 times secant of t, and dx is 4 tangent of t secant of t dt. We replace here. This factor is x squared. 4 secant of t squared is 16 secant squared of t. And this other factor is dx, 4 tangent of t times secant of t dt. Here I forgot to put the dt here. And the denominator here we have x squared, this term here, minus 16. And here we multiply 16 times 4, we get 64. And on the denominator we can factor the 16. We can take it out of the square root sign, and here is when we use the identity. We have this identity, but that means that secant square of t minus 1 equals tangent square of t. And this expression on the left side is what we have inside the square root. So we can replace this by tangent of t. We do that, we'll replace the square root by tangent of t, and we have a tangent of t also in the numerator, so it cancels out. And 64 divided by 4 is 16. So we get the 16 times the integral of secant cube of t dt. And so this means that we only need to solve this integral. But it happens that this integral is not easy to solve. It is a trigonometric integral, and it is solved using integration by parts. We're not going to do that here. I'm going to show you the answer. If you solve this integral using integration by parts, you'll get to this expression. It is quite a hairy expression. 4 secant of t tangent of t. There is 8 secant of t tangent of t plus 8 natural log of secant of t plus tangent of t plus c. Now we only need to substitute that. And remember that our substitution was this one. X equals 4 secant of t. And that means that secant of t equals 4x over 4. But we have t here, No, we have tangent of t. So we also need to express tangent of t as a function of x. And using the trig identity, we can solve for tangent of t to get this, and replacing secant square of t by x squared over 16, we get this expression. And we can take the 16 out of the square root sign. So we substitute back. Secant of t is x over 4, and tangent of t, this expression, we need to substitute in this integral. We substitute, and we get 8 times secant of t, that is x over 4, times tangent of t, that is 1 over 4 times this square root, plus 8, the natural log of secant of t, that is x over 4, plus tangent of t, that is this expression. We can cancel the 8 here with the number 4, and the 2 with this other 4, and we get this final answer. Well, it's not final because well, we need to, well, it is the final answer. And we here replace secant by our original integral to write the final answer. So this is a very long problem, one of the hardest you can find on trig substitution. So that's all for now. Thank you for watching, and see you next time.